A warm welcome from me. My name is Rik. I work for Neo Technology. And yeah, as Alex sort of hinted at, I'm going to take you through a little bit of a personal journey to sort of discuss and explain how I think that graphs are really going to be revolutionizing access and identity management. Probably people don't know this, but I have a a long-standing bit of history in that domain. Long time ago, I used to work for a company called Silverstream Software. Those of you that have been around in the Java world may recall it as one of the first Java app servers, which was acquired by Novell. And I worked at Novell for a couple of years in their identity and access management domain. If you know Novell, or if you remember Novell, you probably recall that they invented the directory server, something called Novell Directory Services, NDS, later called eDirectory, which was a big part of Novell's journey into identity and access management. I later joined a company called Imprivata, which is still around, and did a lot of authentication management, basically managing access for all kinds of different users. And then I left. My last company in that domain was a company called Corion, also still around. It's an access and identity management vendor, doing provisioning systems and all those wonderful things. And to be honest, I left Corion out of frustration. I really did. I think it's solid technology and a great company to work for. But that entire industry, the identity and access management industry, in my opinion at least, is really in disarray. There's a lot of things that are wrong with it, and I find that there's a lot of frustration in the industry with customers in that domain. And funnily enough, after Korean, I joined Neo Technology 2.5 years ago, and I in reflecting on it, I really think that graphs could have probably helped solve some of those issues that I saw in the industry. And then, I'd like to take you through that and sort of explain that and demonstrate that in the next half hour, 45 minutes, and we can discuss it. And I'm sure it won't be a perfect story, but it will be interesting, I hope. For those of you that are not familiar with the wonderful world of graphs and graph databases, 2 minutes, right? We're not talking about charts, right? We are talking about networks. We're talking about networks as invented by this lovely gentleman, Euler. I never thought I'd say it when I was studying his theorems in math classes at university, but I'm probably his biggest fan because he solved a really complicated problem in the 18th century, which was basically a pathfinding problem in the city of Königsberg. If you want to read up on it, it's fascinating, piece of research and applied math, and how he basically calculated that you could not find a route through Königsberg, passing every single street without basically modifying some of the connections between the parts of the city. Right? He basically spotted that there's 4 parts of the city, 7 bridges connecting it, and that all you needed to do was represent that data in a different way, represent it as a network, as a matrix, as a graph, and apply an algorithm to it. In this case, it was very simple. You need to count the edges, establish the degree of every node in this tiny little graph to be able to see that you count to it. I won't go into that today, but we're still standing on this man's shoulder today when we're talking about graphs and graph databases, and I think it's important to have a little bit of history there. We're applying it every day. Graph databases, obviously Neo4j is a graph database. It's an example of such a new kind of NoSQL style task-oriented database that is very well suited to do certain kinds of things with data. OLTP online, facing end user transactions between a web request and a web response, and dealing with that data in the shape of a network, in the shape of a graph. Right? We model, we store, we manage the data as a graph, and represent that data in the form of nodes and relationships. Euler called them vertices and edges. in the database world, we're more familiar with this terminology. Nodes essentially are the equivalent of a record in a relational database table, right? It's an instance of an entity. Right? It could be a phone, a screen, a computer, a mug, a pen, a tablet, whatever you see in front of you, it's an instance of an entity, right? And the relationships connect those entities together, right? They explicitly connect those nodes together, provide structure to the graph, and explicitly tell you something about how things are related. The equivalent of the relationship in the relational database world would be the join operation. So if you think about it, the relationship effectively represents the pre-calculated, persisted, explicitly stored join operation in a network. Right? So that's important. Right? If you see side by side, it would look a little bit like this. On the right-hand side, you see the relational representation of a data model of customers and accounts. Right? You've got one table for customers, one for accounts, and a join table in the middle connecting the customers to their accounts. And on the left-hand side, you've got the same kind of representation, but as a network, as a graph. Right, so you've got one customer node, the red node called Alice. You've got 3 accounts, Alice's accounts, who are explicitly connected to the red node by an owns relationship. So no more join tables, they are effectively replaced by these explicitly pre-calculated join operations, aka the relationship. Right? So that's all you need to know, really, except for the fact that maybe it might matter to, from a general point of view, understand what these things are really good at, right? And then we'll dive into the identity and access problem domain. And from a high-level perspective, graphs are really good at complex queries, right? It's about the depth or the connectedness in the data and the questions that you want to ask of the data. Right? Typically, those complex queries in a relational world, you would have to pre-calculate them. You would have to, put them into some kind of a data warehouse, do some kind of modeling and create a cube for a specific query, do the pre-calculation, and then you would expose it to an end user. Right? Here, essentially what you're doing is you're representing the data as a network, and then you can do all kinds of complex queries on it. What we mean with complex queries is, first of all, queries that involve semi-structure. Right? And the classical example is semi-structure in a data set is contact information. Not everyone has the same contact information. Some people have one email address, some people have multiple email addresses, some people have a Facebook account, some people have a WhatsApp account, so other people don't, right? And you can't connect to them that way. So that means in a relational world that you would have sparse tables. You would have tables with holes in them, null values. And that essentially creates complexity for the application developer. Right? In a graph world, that would just mean that a relationship to a node simply wouldn't exist. Right? There's no need of sort of trying to cram it into a normalized data structure of some kind. You can just not have that part of the structure exist. Right? It's a lot easier to deal with complexity due to semi-structure. But the more important type of complexity that we see in networks is the connectedness, is the density of the connections between different data elements, right? Because typically you will see that reality is very connected, and that the relational model forces a compromise on us that really isn't that natural, right? Which makes asking these specific types of questions like deep joins or recursive joins or open-ended queries or path-finding operations makes those really difficult to do in a relational world and very easy to do in a graph world. Right. There's lots of examples of that. It's applied in social network applications. It's applied in impact analysis applications where you're trying to model configuration management databases in a network. It's applied in route finding applications like, for example, tube routing or rail network routing or something like that. It's applied in recommendation systems like, for example, product networks that Amazon has so cleverly exploited. It's applied in risk analysis in the banking industry. It's applied in logistics, and of course, it's also applied in security, in entitlement management, in identity and access management, which is what we'll be talking about for the rest of this webinar. So let's dive in here. Let's talk a little bit more about how I think that graphs revolutionize identity and access management. And I must say, I got a lot of inspiration from a talk that was done by a Gartner analyst called Ian Glazer. And I want to give him due credit because he, we'll include the links in this slide deck as well. Ian Glazer basically said, that he thought that identity and access management had to be killed in order to reinvent itself. And there were three basic reasons why he thought that it needed to happen, right? And I think I really agree with this because I've lived it in my previous life at those identity and access management companies. The first reason is that identity and access management these days typically has a very static view of the world, right? It still thinks that add, move, leave operations are what it's all about, and that the identities that are subject of these add, move, leave operations are created, managed, owned by the enterprise, right? And that's just not the case anymore, right? There's a lot of reasons why those operations, first of all, need to be a lot more dynamic. They need to be happening much more frequently, much more rapidly, much more in real time than traditional IAM systems are doing. But also, they typically don't rely on the enterprise's control, right? You're leveraging other people's definitions of identities, the OAuth specification that is used by things like Twitter or Facebook authentication, that is a completely different way of dealing with identities. And I think it's a huge source of misalignment and frustration to people like myself in the identity and access management industry, because it becomes so difficult to make this type of solutions, these types of systems, truly matter to business people. Right? And that's just a massive problem, right? If you can't articulate why you need to manage things like identities in a business application, you're really going to miss the boat. Second thing is that it's similar to the previous point, but a little bit different, in the sense that old style identity and access management really is separate of some of the most critical business applications that organizations are using these days, right? There used to be a time where IT was all about, automating internal processes, but those days are over. The critical business applications that people are using these days are applications that interface with the outside world, with partners, with suppliers, with third-party software as a service applications. That's what's really providing differentiation and business value in the IT world these days. It's not about those internal processes that we automated in the 80s and 90s, right? So because of that lack of integration of those externally oriented applications, I think identity and access management often fail. They lack the real business justification, right? They really are too much internally focused, right? And sure, if you're a Fortune 100 company, you might be able to do this. You might still be able to do this, but it's very, very expensive to do so. The average, Belgium, that's where I'm from, corporation can't afford those types of things, right? And they get stuck with an okay solution, and no one wants an okay solution. It's really, really not that great. And many of those problems, I believe, result from the fact that identity and access management is still relying on a very old style representation of identities, access rights, and entitlements. Right? People are still relying on things like LDAP, right? The lightweight directory access protocol that was invented in the 90s to basically solve these types of questions. And hierarchies are just not very good at representing the complex, multi-dimensional world that we live in these days, or that we do business in these days. And Ian Glaser made the point that really what we should be looking at is a network, a graph of access controls. And that's why I really believe that something like Neo4j, a graph database, can help you solve some of those critical challenges that identity and access management faces. We've seen this at customers, and I'd like to help you understand how that's done. Right? How do graphs help? Well, I think there's basically two things. Right? The first is, the high fidelity representation of complex real-world relationships. And I'll explain what I mean with that. And the second thing is that the real-time queries that you're able to do to calculate, to assess access controls in a live system that you can do in a graph database eliminate the need for integration and replication. So let's look at that a little bit more. Right. First of all, identity and access these days in the modern business environment with all of these external constituencies that it needs to service needs to be described in multiple dimensions, right? Think of it as multiple connected hierarchies that basically constitute one access control system, right? It's multiple hierarchies, multiple dimensions of hierarchies that are in some way connected to each other, that overlap. And it's not very difficult to understand that if you have multiple overlapping hierarchies, that what you get is a network, a graph that contains departments, that contains suppliers, partners, assets, roles, projects, all of those things that you need to determine access are going to be part of those many dimensions, right? That is a graph, right? That's the first thing. In that graph, you will find that it's much, much easier to describe things like cross-cutting concerns. And I'll explain that a little bit more. And it also helps you have as many dimensions, as many perspectives as you need in order to deal with application-specific needs. Right, let's dig into that a little bit more. Those cross-cutting concerns that I mentioned earlier, in the identity access world, we have a fantastic acronym for that. It's called RBAC, Role-Based Access Control. Right? People spend millions of dollars on those types of things, on role-based access control systems. Role-based access control systems are all about, stepping away from the traditional hierarchical view of access, right? But talking about these cross-cutting roles, right? And providing people access not just based on their membership of a part of a hierarchy, but based on their role cutting across multiple projects, multiple departments in a matrix, in a graph. RBAC systems, if you read up on the theory that you will find on things like Wikipedia, you will very quickly see that it's all about graph theory, right? RBAC systems are implemented, are conceived based on network theory. But guess what? Almost all of them, in fact, all of them that I know, are implemented on top of a relational database system. That relational database system then manages a provisioning system. That provisioning system then manages the application directory. That application directory then manages the application access. Really? Is that what we want? Is that convoluted setup really what we want? I don't think so. I don't know any RBAC project that was really successful. And I think it's because of that mismatch. It's about that mismatch between what you're trying to do and the technology underneath it, right? At least that's part of the problem. Secondly, part of the reason why this this lack of a high fidelity view on access is a problem is because you are continually working with, integrating with application-specific directories. Yeah, sure, RBAC gives you that graph view of access, right? It tells you these cross-cutting roles in an organization that should drive the access to specific resources. But underneath it, you're still integrating. You're still doing this complex integration project. You're still integrating with those application-specific directories. And guess what? Those are really difficult, right? The reason why those application directories are still necessary in today's identity and access management is because they deal with application-specific models, right? Models that you couldn't integrate into a comprehensive LDAP store, for example. But the vision behind LDAP was, let's create one directory for every application. Well, that didn't work. There's still these application-specific directories because in LDAP, in the hierarchical model that LDAP uses, you can't really deal with those application-specific directories very easily. It's very feasible to do that in a network, in a graph database. So maybe, just maybe, if we were using graph databases as our repository for these multi-dimensional views on access, we wouldn't need to do that integration work. Now, I know I'm talking 10 years out, but it might just be a revolution in access control. And part of the reason why it's going to, or it might be a revolution in access control, is that graphs, if you would use them for modeling access control, are really the perfect tool to interrogate and query for access rights. Right. Graph traversals, as we know them in Neo4j, can perfectly navigate multiple dimensions across multiple connected hierarchies. Right. So it's very easy to, at the same time, query an asset hierarchy, and talk about one specific asset in this complex hierarchy. At the same time, query an organizational hierarchy where we're looking at our role within a specific department of an organization. And at the same time, query, is this person a partner of ours or a supplier of ours? And that hierarchy or setup at least. You can combine all of those perspectives in a graph traversal really easily, as I hope to show you in a couple of minutes. Right. It's a perfect graph application because access control questions are typically very, very graph local, right? They only concern a very specific part of the network. I'm assuming here that you know the difference between graph local and graph global queries, but essentially what I mean with that is that the performance characteristics of these types of questions that you're going to be asking in a graph-based access control model are typically yes or no answers and very local to a specific part of the graph. And they go really, really fast, right? They actually are very, very performant. So having said that, I think this is a good segue to sort of try to prove this to you, or try to illustrate this to you with a short little demonstration. To do that, I've put together a little demonstration database on my local Neo4j server here. So it's not nothing. What I've got here is quite a sizable graph. Right? If I do this, right, you will see that it's got quite a few nodes in there. Right? There's about 750,000 nodes in here. Right? And those nodes, if you look at the Neo4j browser here, you will see different types of nodes here. So for example, here you've got multiple companies. There's about 100 companies here. And forgive the names, I use some kind of a company name generator to do this. All of those companies have different departments, right? So they have a sales department, they have a finance department, they have an IT department, right? So every corporation has a hierarchy underneath it, right? All of those departments have employees, they have people working for them, and there's about 8,000 people in this little network, members of about 100 companies, right? At the same time, you will see that one of the assets of the departments, because the departments have assets, right? One of those assets are files, right? Are file structures. Right, so there's a share for the IT department, there's a share for the operations department, there's a share for the finance department. I mean, every one of those has folders associated with it, subfolders associated with it. So if I keep on clicking here, it's a little bit difficult to see in this small screen, but you'll see there's subfolders, there's files in there. And as you can see, you know, those different types of assets also have a hierarchical structure. So we're looking at multiple hierarchies here, all in the same Neo4j graph database, right? I've got some queries here to illustrate that. So here, for example, what I will show you here is a particular company that I'm very fond of. It's a company called Neotech, right? Now let's go through this here a little bit, right? So in Neotech, there's a bunch of assets, right? There's the purple bulbs that you can see here are different types of assets, right? And there's also different departments, right? There's an IT department. I wish there was an IT department in Neotechnology. There's an HR department. There's a marketing department, and there's a sales department that I work in, right? In the sales department, we have a particular asset, which is a sub-asset of the files asset here, that is a share of sales. We also have a person there, you know, working for that department. It's the guy you might know, being me. Within the share of sales, you have different folders, right? Within the folders, you have subfolders, you know, the yellow bulbs over here, but you also have some PowerPoint files. You know, what does a sales person need, right? Within the subfolders, there's also some other files, some text files. You know, you can see the hierarchy there, right? Right. So what I'd love to do now with this little graph that I have here is determine access, right? I'd like to, across those multiple different types of hierarchies that I've got in this one graph database, determine certain access rights for certain people, right? And I've got some queries here that help you illustrate that. So for example, here, what I can do is, you know, query for, you know, how many files does this person see? So what I can do there is I grab that person, right? So it's very local in the graph. I grab Rik, right? I grab my, that node specifically. I walk the membership relationship to my department, and then I walk the has access relationship to an asset, right? From that asset, which is a file asset, right, I will walk the part of relationship and see how many files are in that tree, right, and return the count F. Right? And I can see that, you know, if I run this, it goes very quickly, right? It has to run through quite a bit of a tree, but I've got 1,100 files that I've got access to, right? If I want to see which specific files I have access to, you know, I'm going to return f.name and an identifier. Right? That's the internal identifier that Neo4j uses. Right? So I have access to all of these files, right? If I want to find a couple of files that I don't have access to, I have a cipher query for that, right? I can see, okay, match the same pattern there, right? I'm walking from the person to the department to the things that they have access to, and I want to make sure that I don't have access to F, right? So these are files that I don't have access to. And I can test that pretty easily, right? Because here I've got a little query that tries to test for access. Right? What I've got here is I test for a very specific kind of access, right? So first of all, I grab a file, right? I grab a file with a particular identifier, right? And then I test for whether or not there is a pattern, there is a relationship from that file back to me, to person here, right? If that path exists, right, that will mean that there's a count number greater than 1, greater than 0 that is returned, and that means that I have access. True. Right. If I would, for example, let's see here, a list of files that I don't have access to, I'll grab this one here and test, do the same test there, right? It should return an empty result set, because that means that I don't have access. There are no paths. I'm hoping you can see, this is quite, it's not a small graph, 750,000 nodes in here, but the queries are very, very responsive, right? They really snap, and that's because they're so local in the graph. So let's make this even a little bit more complicated by adding the partner graph, right? So if I look at Neotech here, not only does Neotech have, assets, and departments, and within those assets there's different types of sub assets and folders and files, but I also have these partners here, right? I'm in Stockholm right now, so J-Way is right here in the same town, or Open Credo in London. Those are partners of Neo, right? So I can include that part, that perspective, that dimension of access control into my access control questions quite easily, right? So how do I do that? By, for example, I can ask the question, what do those partners, the partners of Neo technology, have access to, right? So in order to do that is I start with Neo technology, I find the partners of Neo technology, and then I figure out, if they have access and to which files that might be then, right? If I run that, I get a list of, I'm just limiting this to a subset, but these are files that the partners have access to. But typically those would be, technical documentation, knowledge documents, whatever, or sales PowerPoint information. It could be whatever, right? So if I wanted to figure out, does a particular company, a particular partner of ours, have access to a particular file, right? I can do the same thing that I just did before, and I can run one of those traversal queries and figure out whether or not a particular partner has access to that particular resource. Same principle, same logic, multiple dimensions into one graph, and querying those with real-time traversal queries, right? So I'm hoping that was a sort of a useful illustration here, and I will be publishing all of these documents and queries in a little demonstration video and a GitHub gist very, very soon. Should be tonight, and we'll share that with you after the webinar as well. So that was the short demonstration that I had in mind for this graph-based access control system, which was a little bit more sophisticated than access control systems as they are currently traditionally implemented using old-style identity and access management. As you can probably tell, that's probably not the only use case for Neo4j in your organization. If you're interested in knowing more, please visit our website. We're revamping this constantly and currently, and you've got a lot of use cases there, a lot of customer case studies, and some of those people really have done a lot of identity and access management. People like Telenor have been doing some fantastic work to model access on a big scale using Neo4j. And you can find those case studies on neo4j.com/customers. There's also a bunch of really useful examples on gist.neo4j.org. I'll probably make one of those around this data set as well, and of course you're very happy to talk to us about Neo4j specifically, you know, which version of Neo4j is most applicable for your use case, and you're very much invited to some of our future trainings and events. You know, go for neo4j.com/events, and you'll find more information over there. With that, I'm going to wrap up my little presentation here. I hope it was useful for you, and I'm very, very open to answering any questions if that would be useful.